Hey guys, this is the video for 7-1, and I'm going to go over each section of the homework in the video. All right. Tanya is the first section. Okay, wait, back up. Homework. Don't forget, guys, you have a vocabulary word. There still have a handful of you that skip the vocabulary, whether on accident or on purpose. Remember, you get a point deduction for that, or 2 points. I mean, one vocabulary word, I'm going to take off 1 point. But if it's a big vocabulary section, you skip it, that's a couple points. All right, in the first problem set, you're being asked to write an equation. It might be standard form, it might be y equals mx plus b form, but it's not going to be an equation, it's going to be an inequality, linear inequality. So we're looking for keywords to help us set up the inequality and so forth. All right, so Hero needs to buy new pens and pencils for school. Pens cost $1 each and pencils cost $2.50 each. He has $10 to spend. Okay, so we're going to make pencils X and we're going to make pens Y. Unfortunately, I would have preferred to use letters for them, but they both start with P, so we'll just say X and Y. So this sounds like a standard form equation because they both say each. Okay, so he can buy some pencils for $1 each, and he can buy some pens for $2.50 each, and he has $10 to spend, but we're not using an equal sign. We're using an inequality sign. All right, now he can't spend more than he has, so he has to spend less than $10, but he also could spend exactly $10. Okay. Patty makes decorative flower pots. It costs her $20 to purchase the materials for each pot. She wants to charge more than $6 per hour of labor plus her materials for each pot. So $20 to purchase the materials, that sounds like a y-intercept, and $6 per hour of labor. That sounds like a rate of change. So, it sounds like the money she is going to get, all right, her money is going to equal, but not equal, because these are not equations. These are inequalities. She wants her money to be greater than $6 per hour of labor plus $20 for materials. So that one comes out as a y equals mx plus b. This next section, super easy, guys. If you blink, you're going to miss it. Tell whether the graph will have a dashed line or a solid line. Explain your reasoning. Guys, you don't need to explain it. It's a super easy section, okay? Just tell me, is it dashed or solid, okay? So, like the example problem has an equal bar, so it's going to be solid. 8, dashed, because there's no equal bar. Okay, 10, solid, because there's an equal bar. That's literally it, okay? I could make you explain the reasoning, but it's the same every time. Equal bar, no equal bar. That's it. For this section, you're subbing in 0, 0 to determine if the half plane that has 0, 0 in it should be shaded or not shaded. So you can see in the example problem that when they sub in 0 for x and y, they get a true statement. 0 is greater than negative 13. So the part of the graph that includes 0, 0 should be shaded because the inequality is true for that point. So if we were doing number 16, 0 minus 30 is less than or equal to 9 times 0. Okay, so negative 30 less than or equal to 0. Okay, well that's true. So the half plane with 0, 0 should be shaded. Okay, in 17, negative 8 times 0 greater than 6 times 0 plus 12. Well, this is just 0. 6 times 0 is 0, plus 12 is 12. 0 greater than 12? No, that's false. So the half plane with 0, 0 should not be shaded. That's what that section is asking you to do. All right, in this section, they're asking you to graph inequalities. If it's like number 21 and it's in y equals mx plus b form, then you can just go into your calculator, into your y equals, and punch in your values, or punch in your equation. Okay, so okay, 4x plus 2. Get your table. Okay, stop. Use that table, make your graph. Now look at here how they used a dashed line. They did not connect those dots with solid. That's because there's no equal bar. Okay, now then the shading. How do you decide to color? Well, there's two ways you can think about it. One way that always works no matter what the format of the equation is the 0, 0 method. So you put 0 in for y, and you put 0 in for x, and you see what you get. So 0 less than, let's see, 4 times 0 is 0, plus that's 2. Okay, is 0 less than 2? Yes, that's true. So here's the origin, here's the dotted line. I colored, this is true, so I colored toward the origin. Okay, so that's a method that always works. Now, what happens if my equation is not in y equals mx plus b form? Well, I could take my equation, like number 24 is not. I could rearrange it for y equals mx plus b form. However, if it's in standard form, it's easier to just find the x-intercept and the y-intercept and graph it from there. So because sometimes if you're rearranging for y, you might have a situation where you're dividing by a negative, and if you ever divide by a negative, it flips the inequality sign, and that can mess you up. So I'm going to say that if it's in standard form, the easiest thing to do is find the intercepts. So that would be saying negative x equals 1 and y equals 1. You would just take the x term, set it equal to 1, and the y term and set it equal to 1. Now, this is a weird example because they are equal, they don't have any coefficients. So this x would actually be equal to positive 1, and that's already equal to negative 1. The example in class was better. Okay, x equals 1, y equals 1, and then we connect the dots. And make a line. Except that I just made the classic error. I was seeing if you were paying attention of the fact that there is no equal bar here. So now I got to go back and make this a dashed line. Okay, that's a mistake I make all the time because this is probably the only chapter this year we have to do that. Okay, and I'm going to pause this. Okay, so then we have to decide which way we're going to color. So we're going to use the origin method. So we're going to place a 0, sub in a 0 for x and y, and we want to see if it's true. So 0 and 0, that's just all 0. Is 0 greater than 1? No, that's false. So if it's false, I'm going to color away from the origin. Okay, let's look at that one more time with number 25. Number 25 is also standard form. So first we're going to find the intercepts. So 3x equals 8 and 4y equals 8. Divide by 3, divide by 3. 2.6 repeating. That's right about here is my x-intercept. Divide both sides by 4, and y equals 2. Now, again, since we're only using the intercepts to graph, I would highly encourage you to use a ruler at this point. I'm going to use the line tool on what do you call it here? Active Inspire. Okay. And I'm off a little bit. Okay, I would encourage you to use a ruler. Now, I used a solid line this time. Why? Because I have an equal bar. Okay, then to decide my coloring, I'm going to sub in 0 for x and y. So 3 times 0 minus 4 times 0, and I want to know if that's greater than or equal to 8. So 0, take away 0 is 0. Okay, 0 is not greater than 8. That's false. So I'm going to color away from the origin. And the very last section is word problems, where we're given the inequality. So we graph it, just like we did in the previous section. And then we're being asked if a particular ordered pair is a solution or is not. And you can see that 6, 3 is not a solution because if you have it graphed right, it's in the white zone. And in the white zone means it's not a solution. Now be careful with this section. Okay, one thing I want to show you. Be careful in determining if something is a solution or not a solution. Hold on. Okay. When you have a dotted line, color this in. Okay, something that is in the green zone is a solution. Something that is not that's in the white zone is not a solution. Something that is right on the dotted line itself is not a solution if it's dashed. Because dashed lines come from when it's not equal to. There's no equal bar. So that represents the border, but it does not represent the solution. Okay? Now, if we change this, if I change this and this was a solid line instead of a dashed line, then this is a solution. Because a solid line indicates equal to, and if it can be equal to, then it's allowed, and it is a solution. So be careful in that last section. Look for problems that come out that way. All right, guys, thanks a lot. Have a good day. See you next time.